To solve related rates problems, we shall use all these formulas. The first one is known as Pythagoras theorem. The second one is a property of the similar triangles. Similar triangles are those triangles which are different in sizes but same in shape. If we are given two similar triangles, their corresponding ratios are equal, which means that y by x is equal to b by a. Similarly, y by r is equal to b by r, x by r is equal to a by r, and so on. In trigonometry, we know that tangent theta is equal to y by x. Area of a rectangle is equal to length into width of the rectangle. Parameter of a rectangle is equal to 2 into length plus 2 into width. Area of a circle is pi r square and area of a surface is 4 pi r square. Volume of a sphere is equal to 4 by 3 pi r cube, and volume of a cane, which is a cylindrical cane, is equal to pi r square h. Volume of cone, that is equal to 1 over 3 pi r square h. To solve related rates problems, first of all collect all the data given in the question and then construct a possible figure. In this example, we are given a 30-meter long ladder which is placed against a wall. Its bottom is at 18-meter distance from the wall. The ladder is sliding away from the wall at a speed of 2 meters per second. We have to obtain that at which rate the top of this ladder is sliding down. Here we use the Pythagoras theorem. X square plus y square is equal to r square. The value of r, which is the length of the ladder, is constant 30 meters. Substitute it in this equation, and after simplifying we get equation number 1. The value of x and the value of r is given. We need to find the value of y, so substitute the value of x in equation number 1 and we simplify it to get the value of y, which is 24 meters. Now differentiate equation 1 with respect to t. Differentiation of x square is 2x into dx over dt. Differentiation of y square is 2y dy by dt, and differentiation of constant is 0. Now shift this term to the right hand side. Divide both sides by 2y, we get this equation. Now substitute the value of x, which is 18, the value of y, which is 24, and the value of dx over dt, which is 2. After simplification, we get minus 1.5 meters per second. The negative sign shows that the ladder is sliding down. Hence, the ladder is sliding down at a speed of 1.5 meters per second. In this example, we are given that a stone is dropped in a still water which produces circular ripples. The radius of the circle is given, which is 10 meters, and it is increasing at a rate of 0.5 meter per second. We need to find the rate of increase of the area of this circle. Area of a circle is equal to pi r square. Differentiating both sides with respect to t, differentiation of r square is 2r into dr over dt. Substitute the value of r, which is 10, and the value of dr over dt, which is 0.5. After simplification, we get 10 pi. Substituting the value of pi, which is 3.14, after simplification, we get the required answer. Hence, the area of the circle is increasing at a rate of 31.4 meters square per second. In this example, we are given a round balloon which is being inflated. The radius of this circular balloon is given, which is 5 centimeter, and it is increasing at the rate of 2 centimeter per minute. We have to find that at which rate the volume of this balloon is increasing. Volume of a sphere is equal to 4 by 3 pi r cube. Differentiating both sides of this equation, differentiation of r cube is 3r square into dr over dt. 3 will cancel with 3 and we get this equation. Substitute the value of r, which is 5, and the value of dr over dt, which is 2. Multiplying, we get 200 pi. Plug in the value of pi, which is 3.14, and after multiplication, we get the required solution. Hence, the volume of this balloon is increasing at the speed of 628 centimeter cube per minute. In this example, a cylindrical cane is given which is full of juice. The radius of this cane is 10 centimeter. The juice is going out from this cane and the volume is decreasing at the rate of 5 centimeter cube per second. We need to find that at which rate the height of the juice inside the cane will decrease. Volume of a cane is pi r square h. Differentiating both sides, on the right hand side, we apply the product rule. Differentiation of r square is 2r into dr over dt. Now substitute the value of r, which is 10, and since r is constant, its differentiation is 0. After simplification, we get this equation. Dividing both sides by 100 pi, we get this result. Simplifying 5 and 100, we get 1 over 20 pi. And now substitute the value of pi, which is 3.14, multiplying with 20, we get 62.8. 1 divided by 62.8 give us the required result. Hence, the height of juice in the cane is dropping at the rate of 0.2 centimeter per second. In this example, we are given that a man is standing 100 meters away from a building. There is a ball at the top of this building. The angle between the man and the ball is pi by 3. The ball drops and coming down at a speed of 8 meters per second. We have to find the rate of change of angle between the man and the ball. From trigonometry, we know that tangent theta is equal to perpendicular over base. The base is given, which is 100. Substitute its value and differentiate both sides with respect to t. Differentiation of tangent theta is secant square theta into d theta over dt. Now substitute the value of theta, which is pi by 3, and the value of dy by dt, which is 8. We get this result. After simplification, we get the required result. Hence, the angle is changing at the rate of 0.02 radian per second. In example number 6, we are given a rectangle. Its length is 20 feet. Its width is 10 feet. The length is increasing at the rate of 5 feet per second and the width is decreasing at the rate of 2 feet per second. We have to find the rate of change of its area. Area of a rectangle is equal to length into width of the rectangle. Differentiating both sides with respect to t, on the right hand side, we apply the product rule of differentiation. According to this rule, we write first function differentiation of second plus second function differentiation of first. Substituting the value of x, which is 20, dy by dt is minus 2 and y is 10, the value of dx over dt is 5. After simplification, we get the required result. Hence, the area of rectangle is increasing at the rate of 10 feet square per second. Example 7. A 6-foot tall man is 12 feet away from a lamppost and his shadow is 18 feet long. How fast is his shadow changing? If the man starts walking away from the lamppost at a speed of 40 feet per minute. In this question, we shall use the properties of similar triangles. Here we are given that there is a lamppost at point B whose height from the ground is unknown. At 12 feet distance from the lamp, there is a man. His height is 6 feet and his shadow is 18 feet. We summarize this data and write DE, which is height of the man, CD, which is his shadow, and AC is equal to 18 plus 12. Comparing two triangles, one is the bigger triangle ABC, the other is smaller triangle inside it, DEC. From the big triangle, we write perpendicular over base, AB over AC. From the smaller triangle, we write perpendicular over base, DE over CD. Now substitute values from the above data, and after simplification, we get that AB is equal to 10. In the question, it is told that the man starts moving away from the lamp at a speed of 40 feet per minute. Now when he starts moving, his distance from the lamp will change, so it will become variable x. And the length of his shadow will also change, and we will denote it by another variable y. So we have to find the rate of change of his shadow, dy by dt. Now, using the same procedure by comparing the bigger triangle with the smaller triangle, we write perpendicular over base, AB over AC, and then the smaller triangle, perpendicular over base, DE over CD. Substituting the value of AB, which we have just obtained, it is 10. AC, this is x plus y, equal to DE, which is height of the man, equal to 6, divided by CD. CD is the length of the shadow, which is y. We get this equation. By cross multiplication, we get this one, and when we multiply 6 with x and with y, we get this equation. We further simplify it and get y is equal to 3 by 2x. Differentiating both sides with respect to t and then substituting the value of dx over dt, which is 40, we get the required solution. Hence, the shadow of the man is changing at the speed of 60 feet per minute. Example 8. A conical water tank is 24 feet high with a base radius of 12 feet. Water is being added to the tank at a rate of 20 cubic feet per minute. How quickly is the water level rising when the water is 10 feet deep? In this question, we are given a water tank whose shape is a cone. The total height of the cone is 24 feet. The radius of its base is 12 feet. There is water in the tank whose height is 10 feet. Radius of the water surface AB is R, which is unknown. So we shall use the properties of similar triangles to find the value of R. There are two triangles, A, B, C. The other triangle is D, E, C. Comparing these two triangles in a similar way, just like in the previous example, we write AB divided by AC, just like here, is equal to DE divided by DC, and now we substitute the value of AB, which is R, AC is H, DE is 12, DC is 24, as we can see in this data. Simplifying, we get that R is equal to 1 over 2H. The water is added in this tank and the volume of the water is increasing at the rate of 20 feet cube per minute. We have to find that at which rate the height of this water is rising up. Volume of a cone is equal to 1 over 3 pi r square h. Substitute 1 in 2, we get this result. After simplification, we have V is equal to 1 over 12 pi h cube. Differentiating both sides with respect to t And after simplification we get dv over dt is equal to 1 over 4 pi h square d over dt of h. Substituting the value of dv over dt, which is 20, the value of h, which is 10, and simplifying this. After simplification we get that dh over dt is equal to 4 by 5 pi. The value of pi is 3.14, and after simplification we get the required result. Hence, the water level is rising at the rate of 0.25 feet per minute. That's all.